So don't be too much avoiding the silence, but we're still waiting for some people to come in, and then we start the session. We're already filled with a lot of people here in our room. It's 42 at the moment, but still people are trying to come in, I see. So we give us 2 to 3 more minutes, and then we start with our talk from Shaaron. For all new members, we're still online and your audio is working. We're still waiting for at least 1 more minute now for more people to come in, and then we start the session. Right, I think we're at the point where no more people coming, so we can start. Julian?
All right. I hope you can hear me. Hello, everyone. Welcome to the second lecture of the web lecture series organized by SIG, SIG, and 7. Today, we will hear a lecture from Shaaron Ainsworth from the University of Nottingham in the UK. We approached her and asked her if she would be willing to give a lecture in the series because Shaaron has very substantially affected our field with her research on learning from multiple external representations, the DEFT framework, designs, functions, tasks for learning with multiple representations, I think published in 2006, has lots more than 2,500 citations on Google Scholar and is probably one of the best known publications by Shaaron. And at least from my view, you cannot do research on multiple representations without being influenced by this seminal publication. Shaaron has also been a very productive contributor to the early and 6, 6, and 7 in particular, but unfortunately, she didn't have the time and opportunity to join our conferences in recent years. So this is why we decided to ask her to be the second speaker of our web lecture series, and hopefully we can reconnect with Shaaron by this means. She's here today to give a talk for 45 minutes about designing multi-representational learning reflections from the last 30 years. And we are very much looking forward to this talk. But before I give the floor to Shaaron, here's some important information for the audience. In this session, you cannot interact with Shaaron through audio or video, but throughout the lecture, you can ask your questions via the chat or the Q&A function of Zoom. And we coordinators will collect the questions, organize them a little bit, and ask them on your behalf after the lecture. For this Q&A session, there will be 15 minutes of time after the talk. The whole lecture will be recorded and made available via YouTube and our website afterwards. So hopefully this was sufficient in terms of organization, and now I will leave the floor to Shaaron.
And I will try to share my screen. Please give me a quick thumbs up. Perfect. Thank you very much for having me. It's lovely to be here. I had a quick scan through the list of names on the participants, and I can see some old friends like Ton and Tina, and hopefully some new ones, because as the introduction said, I've been a bit stuck in Nottingham recently, so I've not been able to get to the early in the SIG meeting, so it will be nice to get to know people. So I'm going to talk about something I've been thinking about for a very long time, 30 or so years. And I thought, rather than give you 1 or 2 current experiments, I'd share what I think I've learned over those 30 years. So some will be old, some will be new. Much of it will be very, very opinionated. And I'm probably not even going to apologize for that, but I am just going to say these are my views. And if you would like to disagree with me, ask a question in the chat, contact me by email, because I do love to debate in this area. So why have I called it designing multi-representational learning? Well, I am a learning scientist, and I think one of the things that learning scientists are particularly preoccupied by is design. It's a fundamental method, design-based research, and we spend an awful lot of our time thinking about this word. And I've been trying to think, how do I think about design? Do I think design is a science? Do I think there are principles and immutable laws developed in laboratories that apply? Do I think design is kind of an expression of creativity? It's an expression of artistic understanding. And I think design is best understood as architecture. So we do have some fundamental knowledge, just like we do in physics and fluid dynamics. We do have artistic understanding. We do apply our own vision. We design for a context. We design with clients in mind. So I'm going to say that my metaphor for trying to understand how you integrate scientific understanding, understanding what works in context, and understanding what learners need is to think of design not as science, not as art, but as architecture. Beautiful building, isn't it? It's by the British Iranian architect Zaha Hadid, and it is in Azerbaijan, if you would like to visit it. So with that in mind, my thoughts about design are, this is what I think I've learned about design. I've learned that we should design for different educational purposes, for functions of multiple representations. I think we should design for embodied cognitive, affective and social processes, always remembering those occur in a socio-cultural context. I think we need to design for the fact that learners are developing their understanding. We are not designing for professionals, we're not designing for experts, we're designing for people who are learning through representations. I think we need to design activities and not just representations. And I think we need to let learners sometimes design their own multiple representations. So those are the 5 areas of my talk, which reminds me, I'm going to set my timer. And I'm going to present some evidence, some argument, but not massive of detail to underpin these claims. There is evidence for them, and again, email me if you'd like some studies and stuff later. So, as the introduction said, I've been working on multiple representations for quite a long time. And so it's not unusual for me when I'm in a workshop or a conference for somebody to come up to me and sort of announce slightly proudly that they're using multiple representations. And my most common question back, and I think the most important question, is why? Why are you using multiple representations? And over the years, I've collected a bunch of answers. So I collect answers like, well, I'm designing an environment to help learners learn how to solve complex problems. There are multiple solutions, there are multiple steps. And I like an answer like that. I like it when people tell me, you know, I've got different information to display, and some of it is at really different granularity and really different scale. So I can't fit it into one representation. And I think, yeah, that's good. You know, to help learners understand a representation, a concept, a procedure they've not seen before, or maybe build on some partial understanding. Happy with that. It'll help me remember. Of course, that's a good thing. To learn the practices of a discipline, I would say you can't be a geologist, a radiographer, a physicist, a fashion designer without knowing how representations are used in your professional discipline. So we've got to teach learners how to do it. And I think engaging interest, motivation, curiosity are really good reasons to use multiple representations. But I don't think it's a good idea when we're trying to match to children's specific learning styles. That was an answer I probably got very, very frequently 20, 25 years ago. I'd be surprised if many people today wandered up, certainly on this call, to give me that explanation. But perhaps slightly more controversially, I don't like somebody who says, because learning is better when it includes text and pictures. So for me, that's telling an answer, but we haven't actually worked out what the question is. And it has also, for me, too many boundary conditions. What text? What pictures? So I'll try and convince you that that's too general an answer to be helpful. So this is the answer I typically provide, and I've been providing it actually. Here's a lesson for any PhD students on the call. Be careful what you write in the last chapter of your thesis, because I put this in my thesis in 1996 and then published it in 1999 and 2006. And I don't massively disagree with it still, all these years later. So I think the best reasons to use multiple representations are because they have complementary roles. So we might need to support different processes, perceptual processes. We might need to support inference, but we might need precise read-off. Table for precise read-off, graph for perceptual inference. And sometimes we just need to present different information. And it's too complicated to get like a London Underground map station connections and the real physical distance between stuff on one representation. So move between a map and a functional map of the Underground. So I think those are really good reasons. I like thinking about constraint. So constraint in English comes with a negative connotation, but I actually mean it really positively. So I would say that if you need to understand a new and complicated representation and you don't know how to do it, then a familiar representation can help. You know, my classic example would be something like a simulation where you've got a velocity time graph moving. And we know that children are likely to think that a straight line on a velocity time graph means no motion. But when that is constrained by a familiar representation, like a concrete simulation, where you can see the skater is still moving, even though the velocity time graph is flat. So constraints are a good reason. And finally, we have the holy grail of multiple representation research, that we think by using more than one representation, we can help learners construct deeper understanding. So I call it the holy grail because the evidence for it is not as strong as we would like it to be. But I think you can see it. So I think when you see things like children learning to solve quadratic equations by understanding how a quadratic equation describes the area of a square and manipulating that square to manipulate the equation, then I think you can really see deeper understanding come from this. So these are the kind of answers I would give to why we should use multiple representations. So I'm going to rattle through because of time. So the next thing I would say is we shouldn't just design for one explanation for why representations support learning. So I think at the moment that we should design for embodied cognitive and metacognitive, affective, i.e. emotional, and social processes within a cultural context. So I've never really thought that one explanation is sufficient to understand something as complex as multi-representational learning. And many of the things I would talk about, if you weren't such expert in this area, would come from the cognitive. So I'd be talking about the attentional benefits, the perceptual benefits, the cognitive, long-term, short-term memory benefits. But I've decided that I'm going to skip all of that today because I think you know it already. What I am going to try and talk about more is how I see culture overarching this, and then just talk a little bit about expressive properties of representation and how those can support social and affective processes. So if you were a sociocultural theorist, and most people in 6.6 and 6.7 are not, but if you were, you would see to them their definition of learning is really fundamentally representational. To learn as a human is to take up physical or representational artifacts and their associated practices. So the language might differ. It might be called signs. There might be more focus perhaps on text than there would be in my work. But this idea that learning itself as a human is understood as learning representational artifacts and practices is obviously something I find very resonant. And within that view, then if learning is this for humans, then obviously this is really unique, really distinctive and fundamentally important, because culture accumulates. We say culture is cumulative, i.e. we don't forget things that have happened earlier in our culture, but we improve upon them, use them, modify them, and improve them. So if this was the practice of making a stone axe 50,000, 100,000, 200,000 years ago, the only way that you would do this within your tribe, so you'd learn how to make a stone axe, you'd use it, you'd modify it and improve it, and then within that tribe, future generations would have access to that cumulative knowledge. But the only way for that practice to spread would be through meeting somebody from that tribe. But representational practices, which we think evolved roughly 50,000 years ago, change that. Because learning is no longer just transient and imitative. Learning now happens through representation. So the fact that our culture accumulates is how representations get shared, but probably we wouldn't be able to do this if representations weren't part of our repertoire. So for me, a cave painting on a wall isn't distinctly different to an augmented reality app. They're just a continuous, cumulative way of allowing the external environment to be shaped by and to shape culture. So therefore, under this view, representations are at the center of this community, of this cultural practice. So you don't just understand them by looking at them, you understand them through acting with them and through them in order to perform a culturally valued activity. So you just don't draw or scribble letters to yourself, you're drawing for a purpose, and a purpose that is valued within your community. So I think if you think about representation like that, it shapes all of the ways you think about the processes of learning with representation. Okay, got a strange build going on. I understand why. So there is a sort of exception to that claim. So people like Keith Stenning would say that actually some representations have properties that are the same, irrespective of who is interpreting them. So a computer would form the same kind of interpretation as a human. Now, I slightly disagree with him, but I think there are some interesting points to think about this. So I'm guessing that SIG 6 and SIG 7 will know this more through Wolfgang Schnotz's work around depiction. So just for a second, indulge me and imagine in your head the sentence, "The knife is by the fork." Oops, come back. So there is nothing in the sentence, "The knife is by the fork," that will make it clear whether we are talking about a fork to the left or the right of the knife. So this visual is more depictive, i.e. less expressive, it's more specific. And you might think I'm only trying to make a point about the knife being on the left or the right of the fork, but I'm not. Is your knife straight or is it serrated? Is the handle made of the same property as the end? How many prongs are on your fork? Is your fork bent? Is it straight? And I could go on. So I think if I wanted to pick, let's say, this one here, to actually describe "the knife is by the fork" in text, wouldn't just require a sentence, it would require many, many, many words. So this isn't trying to say that words are bad and pictures are good. It's trying to say that sometimes representations have inherent properties and we have to commit to them if we are to use a pictorial representation. But we can remain fluid, ambiguous, which gives us lots of advantages in text, but it comes with the fact that we may form a different interpretation than the one intended. So I think the depictive properties, specific properties of representation, underlie and might be often ignored in our explanations of the way they influence cognitive, affective, and social processes. I think we should stop ignoring it. It's quite important. And we don't always ignore it, but perhaps we don't give it the attention it desires. And another thing, when I'm designing, I think about designing for social functions. So representations are amazing at mediating communication. So if we're talking about talk here, obviously talk itself is is a representational medium. But if we are thinking about external representations such as cave paintings, augmented reality, simulations, pictures, diagrams, then we do amazing things when we have these representations in front of us. They ground communication. They permit collaboration. So much of what we do when we're working together with representations is based on us having this joint focus on a shared representation. So yes, we talk about them. But if I don't know what to call something, I can just gesture towards it and you'll follow my hand, and we'll develop this new understanding through collaborating around the representation. And if we create a representation together, then that representation that we've created together becomes a resource for social negotiation. So my representation and your representation, we have to create a new one that supports both perspectives. So perhaps, in fact, frequently we lose a little bit of detail because your detail and my detail might be slightly different, but our underlying ideas might be the same. So that it becomes a little more abstracted, and it becomes a place where we have to argue and talk with one another in order to agree what to represent. So there is interesting work around some linguists that also suggest that it's this process of social negotiation that turned graphical representations into written textual ones in the first place. They became more abstract because of the way we needed to negotiate meaning from them. So my stick to stand for something in a hieroglyph and your stick, which is slightly differently drawn, they just become eventually the notion of stick rather than my read, your read. And final thing I just want to talk about processes is emotion or effect. I think it's still badly under theorized in our fields. We probably still need to do better because, you know, if you talk to classroom teachers or museum curators about what they're thinking about when they're designing representational displays, they are really focused on how they excite interest, curiosity, engagement. If the learners are not interested in a museum, they'll just walk on by. In a classroom, they'll superficially engage, but they'll be looking out the window and counting the minutes till break. So how can we design representations better for these affective processes? And I personally struggle to find representations like that affective or engaging. Many people do, but not everybody. So there are clear individual differences in what is engaging. And this is the sort of thing I like. This I actually mentioned when I gave my last 667 talk in, we think, 2008 or something like that, or 6 or 4. None of us can remember. I like representational systems which are really sensitively designed to support affective processing. So this was a game Jake Habgood and I developed a long time ago, and it's about teaching children about multiplication and division by allowing them to act on the representational systems. So they pick up, in this case, a shield of 3, and a shield of 3 will divide 6 by 2 and 9 by 3. But if you try and bash this shield into a zombie with 5 on its chest, it will fight you back. So the engagement with this representational system was through the roof. We have never seen children as intrinsically motivated to learn their multiplication and division as we did when we put sums in the context of zombie fighting. And this is what I hate about emotion and affective design. So here's just a 2-page textbook from one of our common science textbooks for 11 to 12-year-olds. And over here, we have this photograph in a page, and our representational textbooks, our textbooks are now full of representations. Though, you know, every page, typically up to the age of 16, will have as many, you know, pictures, diagrams, graphs as it will have in text. But I really hate this one. Let's zoom in on it. And I hate this one because I think it has been put to fill up a space and superficially entertain. So he's an ecologist and ha-ha, his name is Plant. Isn't that funny? And that means you don't have to do anything with this picture. It's not really adding to your understanding. It's there because somebody needs to fill up a space and they think this is a funny thing. And one of the times I was giving a talk about this and somebody said, oh, but that is really interesting. I wonder whether that affected, you know, how he came to be an ecologist. And I said, but that's not what the purpose of this page is. So if you're thinking about that, it is a seductive detail. It's taking you away from what you should be thinking about. So I think design for cognition, design for social interaction, design for affect, design knowing that there are expressive properties of representation and that everything happens in a socio-cultural context. The next thing I think I've learned is to design for learners developing understanding. So back to my favorite textbook. Actually, I've got so many pages, but as I'm short of time, we'll just stick on this one. And let's have a look at this one in detail. So this is the human life cycle. If my panelists who I could see could nod if they think they understand it, great. So let me tell you, I'm from Mars and I'm just going to read off what I see. So I see a woman in a fetching orange jumpsuit and waistcoat turn into a fertilized egg cell that turns into a baby, that turns into a toddler, that turns into a boy, that turns into a girl, that turns into an adult male. And then something happens, right? So my point here is this representation could not be more straightforward to read, but we only understand it because we already understand what it's trying to tell us. If we don't understand what it's trying to tell us, we will learn completely the wrong things because humans are not parrotfishes and mostly we do not change gender multiple times as we develop. So I think over and over again, once we understand the concept and once we understand the representation, we forget what the learner has to do in order to learn this stuff. And if that's hard, one thing that I have been preoccupied on for a very long time is how do we understand the relationship between representations? So, you know, we've had to understand that, but now we've moved to slightly more complicated representations. But is this representation showing the same as this? Is this phase plot showing the same as this time series graph? So this idea that we just bung lots of representations in front of learners because it will help them learn massively underestimates the complexity of understanding representations in isolation and how much they relate to one another. So for me, I think that multi-representational learning is really intertwined. You are learning with representations at the same time you are learning through representations. And perhaps our research studies don't give enough time for learners to do some of this basic learning before we say this representation doesn't help them learn. So I think you have to understand the properties of the representation, its syntax, you know, how do you read a gradient? But then do you look at a gradient or a maxima in order to find a distance traveled on a velocity time graph, for example? How do we translate between the representations? Perhaps if we're in situations where we can select them, how do we choose a good one for the task at hand or our existing knowledge? And how do we construct the representations? We know that there's a difference between reading and writing. And just because you can interpret something doesn't mean you can construct it. It's because really, I think we're looking at helping learners develop representational and meta-representational competence. So we're looking at how they should be able to invent, understand, apply, explain, critique, even invent representations. Because as I said at the beginning, I think representations are things that are used within a community of practice. But also, or perhaps just in summary, we need them to reason with the representations. So we need them to develop that understanding. And meta-representational competence really talks about that outside of a disciplinary knowledge. So we know that a visualization is good if it obeys the standard conventions. So we should design for development, not design for us. My next theme is designing activities, not just representations. So perhaps many of us who work with computer-based learning environments, we often get fixated on the design of what should learners be looking at on the screen. But if I go back to the importance of processes, what we really need to do is, yes, we need to design the representations right, but we also need to design activities that support learners to make meaning with these representations. Because it's the actions and interactions, both with and through representations, where meaning making occurs. So you can put a diagram on a screen. If everybody's got their eyes closed, you're not going to benefit from it. And that's a facile example. But really, we know, and anybody who's spent any time looking at this happening in context, it's really, we need to encourage learners not just to passively process, not just to flick their eyes to a diagram to a couple of seconds, but to engage with that representation to make meaning. So they might be talking about a representation, they might be looking at a graph with a friend. Therefore, they might be gesturing to it, but they may be doing more than gesturing to it. They might be embodying it. You may have come across Katerina and my paper on embodying fish locomotion by using your whole body to copy the videos that you are looking at. You might want to re-represent. So an awful lot of what we do with representations is we transform them from one form to another. We turn that piece of text into a drawing. We look at that graph and we relate it to a table. But there are other kind of less obviously representational things we might do to encourage learners to make meaning. So all sorts of constructive activities, you know, self-explanation, active summarization, rewriting as a mind map. So all of these sorts of things. And sometimes that we might just want learners to observe closely. We want them to relate to what they already know and check their understanding of it. We might want them to critique it. Is this a good representation? There's lots of representations out there. Well, we've just looked at a couple that are really terrible. Why are we putting them in front of learners? We need them to develop their critical skills. And doing all of this, I think, helps learners understand the representation and understand through the representation. And beware passive processes. We know that learners can have metacognitive failure around some forms of representation. And we know that, you know, since Gabby Solomon's great work on TV, that video and animation are particularly prone to illusions of understanding. So if you put a video up in a classroom, if you put an animation up, students sit back in their chair, cross their arms and wait to be entertained. They don't think it's an activity that requires a lot of cognitive processing. So, you know, beware the hands-off, minds-off approach to understanding representation. And in a study with Sandra Nitz, which is probably the only study I've done where I've seen that drawing harms learning, what we think was going on was that teachers were just putting up PowerPoints and getting students to just endlessly copy what they saw in front of them. And that didn't help them learn. And my last theme is let learners design their own representations. So if you have read my history, you will see round about 2005 and 2006, I stopped mostly working on presenting learners with representations, and I started to ask them to make their own. I kind of like a bit of both, but I felt there was more of a gap around making their own. So let them draw. Fascinated by drawing. Terrible drawer, still can learn by drawing. Let them make a model, be that in clay, be that in animation, you know, that kind of 3D chemistry, model building stuff. And when I say 3D, look, I immediately had to gesture. That's interesting. You know, let them draw a little doodle, a little sketch. It doesn't always have to be a perfect representational drawing. Let them gesture, let them symbolize. Let them, you know, write in their own words what they can see in a drawing. So let them make their own. So we might do this when we show them something in real life. So this was, what were we doing? This 9 to 10-year-olds. This is really Russell Tytler and Vaughan Prain's data. So what was happening, there was a teacher was going into a classroom. They were putting their hand onto a damp piece of paper. They were taking their hand away, and the children were asked to draw what would happen invisibly as the hand was taken away and the water evaporated. So there's no right answer here. There's just, these are two different learners' drawings, but they created their own understanding. And then across the class, they had a conversation about how they represent movement on molecules. And you see these three little lines. That was a convention that developed within that culture, such that then that was emerged, understood, modified, and held on as that classroom culture accumulates. Or we could do something like this. So this is working at a very, very different age group. It's working in quantum mechanics. So this is looking at, if you are a physicist, please correct me in chat, time dependence in the infinite well. And learners were looking at this in a simulation, but before they ever saw a representation of the entire function in a 3D representation in the simulation, we asked them to draw what they thought it could look like and what we can see them doing. So this is really an invention to prepare for future learning activity. We weren't looking for a right answer, though we got some right answers. We were looking at them to think about the form the representation could take, and they might extend a previous sketch that they'd made, they might redesign one, they might combine them, they might combine and extend. And this then prepared them for when we showed them some canonical representations in the simulation to learn from. So we've gone from 9-year-olds to 25-year-olds, but drawing is still a good idea. And let's go back to 6-year-olds. So again, it doesn't have to be a formal scientific representation. This can support affective and social processes as well. So in this study, we presented children with animated picture books, but what they did was they drew on top of it. They drew their own annotations. And this enhanced their storytelling. They were more creative in their storytelling. And the people they were telling it to do, their fellow 6 and 7-year-olds, were more engaged. So we can draw what we've understood for multiple reasons. So how am I doing? Oh my gosh, I'm early. So representations, I think, are powerful tools for learning. We ignore them at our peril. We don't think about this enough in our initial teacher education. We don't think about this enough in our public communication. We don't think about this enough in our textbooks, because they are fundamental to how we learn. We learn so much less from direct experience and imitation than we did 100 years ago. And I don't think we're going back to only learning through imitation and direct experience. And I think if we think of these as tools for learning, then we think about selecting the right tool for the job at hand. We wouldn't use a screwdriver to crack this coconut. We wouldn't screw in a nail. No, we wouldn't screw in a screw with a hammer. Well, we might, but it wouldn't go well. So I've resisted principles in all of my work. I don't say, with an animation, never put text. I don't say, with experts use a different representation to novices. It's not that I don't think those are useful generalizations, but I don't think, for me, they work. So I'm going to try and give you my principles, but they're very abstract compared to some of the ones you'll see from other researchers in this field. So for me, a well-designed representation, when I'm giving you an expert one to look at, it manipulates the information. So it shows things in a way to make its task relevant. The key things it's trying to help you learn more accessible to the learner, so they can engage in those beneficial cognitive and metacognitive, social and affective processes. And because I think we're designing for this context, the people that I want to be helping design these representations understand the disciplinary knowledge they're trying to convey and understand the needs of that they're trying to convey it for. So that to me is a well-designed representation for interpretation. But for construction, are all representations good? Well, again, probably externalizing your knowledge probably always helps, but particularly helpful representations are ones where learners generate or invent a representation that expresses their current understanding, but provides a basis for going beyond it. So as Jerome Bruner's academic granddaughter, to me, going beyond the information given is always a thing we want to be encouraging. And if we do that, they can go beyond it in ways that, again, encourage their cognitive, metacognitive, social, and emotional processes. So I can't design for cognition without thinking about emotion, and I can't think about social without designing for metacognitive regulation, which is why I don't write as many papers as I should, because I'm always trying to deal all of the time with all of these explanations at the same time. What else does thinking about tools only being useful in someone's hands tell us? Well, a tool doesn't do anything if it stays in the toolbox. It's actions with the representations that makes the difference. Actions with, actions through. It's got to be active and interactive for it to support learning. And perhaps it helps us remember we don't come out of the womb knowing how to use a screwdriver or knowing how to use a drill. We need to learn how to use representations well. So representational learning to me is always intertwined. We're learning with and about representations simultaneously. And I wouldn't let my 17-year-old drive a car by seeing how well he did on a written text. I would like to see him drive the car before I'm confident that he should go off on the road. So we should assess learning with that tool. There is no point teaching people through diagrams, augmented reality, simulations, and then just asking them to write, even though that is what many, many exam boards do. I think with technology improving and changing, we actually could get back to a point where our assessment might actually also be more visual than at present. So that's what I think I have learned. I've spent 30 years thinking about this, and this is the best I've got to, but I haven't got there alone. So if you would like to disagree with any of these points, briefly email Jake Habgood, Antia Canol, Katerina Scheiter, Julia Gelmini Hornsby. Good luck finding her. She's up a mountain in Italy. Russell Teitler, Gina Besant, Vaughan Prain, and Mike Stye, because these are the people that have probably most helped me recently try to come to these conclusions. And I'm going to, shall I stop sharing? I think that might be a good idea. I'll stop sharing.
Yeah, thank you very, very much, Shaaron, for this very inspiring talk. Very funny also sometimes. Thank you very much. There's time for questions now. I think you can write in the chat on the Q&A, and then we're happy to pose them to Shaaron.
I think I did 39 minutes. Oh.
Yeah, it's perfect. Really perfect. Yeah.
So some more time for questions. Maybe while the others are writing down their questions, I can already start with one question from my side. I really like your idea of giving representations, but also like let learners generate their own representations. And I was wondering, do you have any answer to how dangerous it might be to give representations in schools that build like kind of their first representation of a thing or a concept or anything else? And is there any prototype bias because of representations we give as teachers?
Yeah, I mean, if you think about metaphor, which I often do as a form of representational system, you know, there's such a big debate in the metaphor world about whether, you know, the solar system metaphor and the visual representations that go alongside it actually do more harm than good, as then students move beyond that metaphor as they do, you know, +16 and older study of chemistry. So yeah, I think there is a real danger of not thinking about the representational aspects of the information that we provide to students. When it comes to what we could do about that, I think it can be really interesting to get learners to generate their own before they see the canonical representations of science. Again, if you're following the work of people like Manu Kapoor or Dan Schwartz, you know, this kind of idea that to help you prepare for the future, generate your own first, and then you could critique and see what the differences are between your representation and the canonical ones. And I think the other thing that is really important to do is help our learners become more. So if our teachers are not brilliant at being aware of how representations, you know, are one choice of how we display the information that we want to display, and, you know, lovely work by people like Billy Elam have really looked at how we can integrate this into teacher professional development. But we should also perhaps be doing it with our learners as well. You know, so encouraging, deliberately building on what seems to be some quite good, naive meta-representational competence, but then we sort of stop teaching about that. And we just go, this is what, you know, an electrical circuit diagram looks like. Copy it down, not why have we made these choices. And you know, another one classically is water. You know, when we use blue and red to illustrate the chemists, sorry, blue and white to represent hydrogen and oxygen. There are so many quotes in the science education literature of children going, why isn't water pink? Water should be pink, you know. So I think we've got to help our learners see that these are represent choices and conventions to display conceptual knowledge. So teach for it, I think, on top of hoping it develops naturally. That's a long, vaguely relevant answer to your question.
Oh, thank you so much. Interesting.
Now, there's some more questions. I'll start with the first one. From an anonymous person. I really like your social cultural perspectives, but what is your insight on interaction of language and representations in learning? That's the question.
So I guess we are saying spoken and written language and representation, meaning visual or 3D, because of course language is itself a representational system. But I completely, the way I've been talking about it would lead you to believe that isn't what I think. They are fundamentally intertwined, is how I think about them. If you look into this literature, you will see that a lot of the literature focuses on the development of language, and language as a sign and a way of understanding culture. But I think that more recent accounts really have looked at the way that visual representation integrates and intertwines with language. It's again slightly one of the reasons I don't go for always have a text and picture, because I think you've always got language and around if you're looking at a visual representation. I would say if you're really interested, don't read what I have to say on the matter, read the experts. Go to people like Roger Salio and start there, or Ferenc Martin. These are people, if you are a beginner in this area, you might find it comforting to go to some of the people that try to integrate cognitive and sociocultural explanations. And many Swedish and Norwegian science education researchers try to do this. Although I am a working reference list by this point in my career, the names I most want to get are currently escaping me. But head to Sweden and Norway, go north, and you will find some brilliant integration of cognitive and sociocultural perspectives. I'll probably remember just as the Zoom ends.
Thank you very
Thank
much.
you.
So the next question is by Tina Seufert, and she really likes the idea of tools in action and is asking if there are certain actions that are prone to certain representations.
Hello, Tina. Yes, I think there are. I think that this whole kind of cultural practices with representations makes us think that there are certain actions. It's almost a definition of a representation. We shouldn't really be sort of maybe talking about pictures or models. We should be talking about pictures and the way people draw them and the sort of actions they do to draw them. We shouldn't be talking about a model, but thinking about the actions people do to create, deconstruct, recreate representations. So I think as you see how cognitive psychology has evolved its explanation of what it is to think over the last 20 or 30 years, we can see that the action is so fundamentally important to understand how we think that we should probably integrate them in how we think more frequently. So I would say I'm taking a more embodied perspective on this than when I wrote my thesis in 1996 and put DEFT in it for the first time.
Yeah, thank you so much. I'm really thrilled to see how it works. Maybe there's also another question connected to this. Meg Farrell is asking if whether we can design activities to combat the threats of this illusion of learning that you talked about whenever we learn with video-based learning materials.
Yeah, so there are, I think, a series of research studies that have looked at how we can do this. So, you know, people like Doris Lowalter's work when she looks at constructive strategies, a lot of work that has come out of Rolf Klutzner's lab. You know, essentially, we need to slow learners down and help them think about what is going on. So any kind of constructive processes really help, I think. Don't, like most of our research studies, ignore the importance of the teacher. So, you know, in classroom settings, students have support from their teachers, and their teachers can be helping deal with these threats of illusions of understanding. So they can be stopping videos and animations at important times and pointing out what's going on. But I think there is a nice bunch of work on metacognitive understanding of video and animation that's increasing recently. I think the main trouble we see with that is, of course, because videos and animations are dynamic representations and transient, you know, causing huge problems for working memory and perceptual processes, we probably need to keep stopping them, doing something constructive, restarting, or going through things multiple times. We can't, you know, with a picture, it won't change while you self-explain it, but with a video, it will. So you will be self-explaining something that is no longer on the screen by the time you've got down to finishing your self-explanation. So I think if we really want to make the most of videos and animations, we probably have to put a lot of speed bumps into learning. So maybe let's not control time on task in our studies, because it then disadvantages learning from video.
Right. I was also wondering, can you give us any advice what you think the research on representations and multiple representations needs to examine in the next year? So what is your kind of advice for new researchers? What they should go for, and what is interesting, and what do you think is important also to have a look at?
So probably I always say, think about the explanations that you are providing. So you design your study with a particular hypothesis, and normally that hypothesis will come from a perceptual level or a working memory level. But then you get a result, and your result might be that text and pictures helps you learn more than text alone. I think that's very true. The thing is that a working memory explanation? Or is it an explanation due to effect? Or is it an explanation due to the depictive differences between the text alone and the text plus pictures? Or is it different in the amount of information you've provided? So I think I would say let's all be a bit more critical and assume that the first explanation we have may not be the only explanation. There might be other explanations that we haven't seen. And then where is the wave? Where is the field going? I would like to see it going more up-to-date theoretical approaches. And I'd probably like to see more work on actual reality. So I love a design experiment, but I also think we still need a lot more work done in real context with teachers there supporting learners and assessing learners in ways that are relevant to what we've been trying to teach them. So maybe a bit of real world reality. You know, we will get explanations based on working memory if we ask people without relevant schema to interact with the representation, because definitionally, you know, they are the ones who will be most working memory challenged in this context. So let's just make it a bit realer. Love a bit of lab, love a bit of design, but also like a lot of ethnographies and observation and qualitative work, looking at things in a real world context.
All right. I believe there's time for one more question, I think. Tina asked a second question. Tina Seufert, lately I've been thinking a lot about the challenge that generative AI outputs are nothing more than multiple texts or sometimes other representations that need to be integrated, compared, etc. Do you think your deft functions apply here too?
That's an interesting question, Tina. I can't think why not. So I've been using some of the, you know, Bing Creator and DALL-E and Crayon to create some visual images for me from some text I'm writing at the moment. And it's a very interesting critical activity to write a prompt that generates the type of visual image that I want to get back, and then, you know, integrate that visual image into the text to see whether it really reflects what I wanted to create, because I can't draw and these things can draw. So it's a very interesting multi-representationally world when you're getting this agent to immediately create the visual image of the text you have. So yeah, I think they probably would apply, because I can't think any reason why they wouldn't. But I think it really changes some of the cognitive, affective and social processes. So I'll have a think. If you could have a think too, Tina, and let me know your answer, that would be brilliant. Save me doing the thinking.
Cool. So a quite moment to develop some more interactions between you, but also maybe others would like to contact you after this talk. So yeah, I'm just adding up on your remark. So whenever you want to ask Shaaron some questions, please write her an email. She's open to that.
Yeah, I'm very Googleable. The extra A makes a big difference.
Great. Right. So thank you so much for your presentation. It was very inspiring, and at least also from my research, I'm really inspired by having this notion of that not only cognition is one of the aspects that we should look at, but also affective, social, and cultural components that were neglected for a long time in our community, and maybe we should have a more focus on that. So I'm very much looking forward to more research in that area, and happy to have you here today, and want to say thank you again for your presentation, and have a nice rest of the day. Thank you very much.
And I hope my opinions were just as opinionated as I promised they would be.
Yeah, definitely, definitely. Thank you so much, and
goodbye.
Have a nice day. See you.
Bye.